Hi Sam. I thought I'd do the entire question because it's just weird trying to do B without all this knowledge. So let's just have a look at it. Question 4: a non-uniform rod AB of length 5 meters. So there it is. We've got A, B, non-uniform, so its mass isn't in the center, and mass 15 kilograms, rests horizontally suspended from the ceiling by two vertical strings C and D, where AC is 1 meter. So like that. That is C, and A to D 3.5. So 1, 2, 3.5. So it'll be somewhere over here, somewhere like that. I don't know. D. Okay. So let's get this right. That is 1. 3.5 makes that 2.5. It says, given that the centre of mass of E is at E, where AE is 3 meters, so I know that it's down over here, the centre of mass. Okay, sorry, measurements right, but that's 3.5. It's over here, and we know that it weighs 15 kilograms. That is 15 g. And that's what's going on at the moment. It says find the magnitude of the tensions in the strings. So here we go. Let's call this well, let's just call this C, and let's call this D. Okay, so what I can do is take moments about I don't know, take moments about this point just here. Okay, about C, clockwise is positive, and because it's in equilibrium, we've got the sum of the moments, F times perpendicular distance, is equal to 0. Then we start off by saying the first positive one will be this one here, clockwise, which is 15g, the force 15g, multiplied by its perpendicular distance. Well, if that is 3 meters, I suppose I'll put that on the bottom. 3 meters there. Take one off, that is 2 from that point there. This one is anti-clockwise, so it's a negative moment, and is the force D multiplied by this distance here, which is 2.5. And we know the sum of those moments is equal to 0. So we've got basically 30g minus 2.5d. So therefore, is equal to 0. Therefore, D is equal to whatever 30g is divided by 2.5. Okay, and that is going to give us over here, we've got I'll just do it as a fraction. 30 times 9.8 divided by 2.5 is equal to, SD it, and I get it's because we've got G involved, it's got to be to 3 sig fig, so it's 118 newtons. Okay, then we're looking at part B. So that was part A. It says when a particle of mass 10 kilograms is attached to the rod at F, the rod is just about to rotate about D. Now, when it's talking about just about to rotate about this point here, it means that this has got is providing nothing. The support, the tension in that string is nothing, so you can negate it. If you're just about to rotate, it's not rotating, but you're on the tension there has gradually got less and less because there's weight being put on. That weight needs to be in this region here, okay, to work out, to give us that balance. Okay, so I'm going to put it in this region here. Even if you couldn't see that, you could put that anywhere you wanted, and it would still work things out for you. So it's 10 kilograms, so that is going to be 10g, and the answer is going to be measured from A, find the distance A to F. So that there is the distance I'm going to mark off as X. So well, I just noticed I didn't finish this question off, did I? I didn't find out the other one in D. Let me just finish this question off. Sorry, we know that if we resolve, let me just push it to the right very quickly. Resolve vertically upwards. We know that the sum of the forces, so F equals MA, and we know that it's stationary, so the sum of the forces equals to 0. So what we've got is C and D. So that is a 117 point, I always use the unrounded answer, 0.6. Okay, plus my C is equal to 15g. You could even put minus 15g is equal to 0 and then turn it all around. So therefore C is simply 15g take away 117.6, and that will give us the direction at C. Let's just quickly finish that off. So I've got brackets 15 times 9.8 minus previous answer equals that, which gives us 29.4. So 29.4 newtons in the other arm. Okay, so that's finished off. Back to this question. Okay, so as I said, there's no tension here. If you're just about to spin, this is providing nothing. So that's the diagram. You can negate this. So it's up to you. You can take moments about here, 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 or anywhere, but I'm going to take about here only because X is measured from there. And I've got everything I need to know. You know that if you resolve vertically upwards, okay, using F equals MA, then you know that you've got D minus 15g minus 10g is equal to 0. Therefore, D is equal to 25g newtons. Okay, right, so now I can take moments about A. I mean, you could have taken about D, you didn't have to do this step. But anyway, it takes about A, and we're going to do the sum of the moments. Sum of the F times D is equal to 0. So what I've got, the first clockwise one is this one here. So I have got 15g multiplied by its distance, which is now 3.5. Okay. What's 3.5 yet for A to D? No, that's that. Sorry, it's 3. Yeah, on my diagrams, I should have really done it. Times by 3, because that's the centre of mass. Okay. The other one is also a positive one, this one here, which is going to be 10g multiplied by x, and the other one here, which is D, is a negative, and that is the 3.5. So it is D, which you've just worked out, is 25g multiplied by 3.5, and we know the sum of those moments must equal 0 because we're still just about limiting, we're on the verge of tilting. So working this out, I can see G is in everything, so cancel G. 3 of those is going to be 45 plus 10x minus 3.5 times that. Well, that's going to be 75 plus half that is going to be 12. It's at 87.5. 87.5 is equal to 0. Better check that out as 25 times 3.5 equals SD, and it is 87.5. Right, rearranging that, I've got X is simply equal to 87.5 take away 45 all divided by 10. Okay, so 87.5 minus 45 is equal to, and then divide it by 10, and we get that, which is SD. X has to be 4.25 meters. 4.25 meters. Okay, and that's the answer for that. That's what it means when it's on the verge of tilting. It just means that you can negate this one of the supports. Okay, because it's on about the whole beam is going to rotate about that, so that's giving no support whatsoever at that stage. It's just on the verge. All right, Sam.